So what is an operating system? Well, according to our textbook, an operating system is the low-level software that supports a computer's basic functions such as scheduling tasks and controlling peripherals. That sounds complicated, and yes, it is, but let's try and explain it in more simple terms. You can think of an operating system as a piece of software that makes sure that all the various pieces of hardware work with each other, and more importantly, let you, the end user, tell it what to do when you need to do something. For example, when I'm writing this script, I'm sitting in front of a monitor or a screen, I'm typing away on a keyboard, and I'm using a word processor program to translate my thoughts into text so that I can later read it back and record it for you so you can watch it on another piece of program or a browser, which is also just a program. And all of that just works. If I had to do this in binary or ones and zeros, and we'll get to this a bit later again, that's the language of machines, it would take weeks to do a single script. And I will have to learn every combination of binary, which is a huge task. But since I have an operating system installed on my Mac, and it knows what to do with the keyboard, and it knows what to use with MS Word, I can start typing and I know what I will get because the result will be expected. And expected or predictable results is the main goal of computers. You want to press a button and something needs to happen the same way every single time. Otherwise, what's the point? If I had to go and relearn how to launch a web browser, how to use Word, how to type every single time my computer started up, it will be terrible. Nobody would get anything done. So a good way to think about an operating system is something that can give expected results for hardware. Another way to see it is to think of your operating system as a kind of private butler or servant. You tell the software what you want to do. The action is interpreted by the operating system that knows what hardware driver to engage, and you will get an expected result. You, as the end user, don't need to know what the processor, the memory, the storage, the encoding, or even the kernel is doing. It is all being managed or operated by the system. Hence the name, operating system. Now, clearly, we can't have a one-size-fits-all operating system for every single thing on the planet. It just won't work. So we get various types of operating systems. And inside those types of operating systems, there are various operating systems that have been created to meet specific tasks and goals. Now, we are not going to cover every single operating system ever made in operating system file systems, but we will try and cover the big ones or the historically important ones. I can also see that some of you are already thinking like there might be a difference between what is an operating system and what's the type of operating system. It's important to read a question around that carefully. So let's explain that a little bit better. Let's say I ask you to recommend to me a single user multitasking operating system. You will be correct in saying, hey, that's Windows 10. But if I asked you to tell me what type of operating system can be found in something like an air traffic control tower, and you said to me, Windows Server, Ubuntu Server, or Mac OS, you would actually be wrong. Because the type of operating system found would be a real-time operating system. And if you are very clever and you've done some extra research like we asked you guys to do, you would also say, Janrik, it's probably real-time Linux or RT Linux that's been installed in that operating control tower. So it's important to be curious. It's important to take your notes, and it's really important to what does Janrik mean by that? Maybe I go and look it up if you don't understand completely from the lessons, the LinkedIn, and the Xiling. Right, so let's start with different types of operating systems. And the first one we're going to cover is the real-time operating system. As the name indicates, this is an operating system that is expected to handle a series of tasks or instructions very quickly with almost no user input required. So if you press a button on an elevator and you're on the 10th floor and you want to go to the ground floor, you don't have to program it or tell it to ignore all the other floors. It will automatically go down to the ground floor unless another user interrupts the process. And the elevator will then stop at that level to allow another user on. But if somebody's on the ground floor and they wants to go up and there's only one elevator, they will have to wait until all the processes or people coming down have been actioned. Otherwise, it'll be complete chaos. Nobody would ever know where they are going to end up with or which floors they're going to stop. So, in short, it is called a real-time operating system because you don't want the piece of hardware that you're pressing the button on to go and think about it. Microwaves are also a good example of this because they are pre-programmed with certain settings. You don't have to go through all the little menus to tell it to run for 30 seconds. If you press the start button on most microwaves, it will run for exactly 30 seconds every single time. Or if you press the chicken icon or the pizza icon or the milk icon, it will know that you as the end user have placed a pizza or a piece of chicken or milk or whatever in the machine, and you want it to heat or cook that, and it will have a pre-programmed set of instructions that it will run the same way every single time. That's very important with real-time operating systems. It has to be quick, and it has to do the same thing quickly every single time. There's no room for thinking, and you as the end user shouldn't expect more of it. You're not going to try and play Pac-Man on the control panel of an elevator or on your microwave. Now, granted, some people probably manage to get Doom going on it because that seems to be a thing, but it's not designed for that. Right. The next operating system is what we call a single user operating system. And this sometimes confuses people because some operating systems, like for example, Windows 10, you can have several user accounts created. You can have yourself, your siblings, your wife, your spouse, your friends. They can all have profiles or accounts on your system. But only one person can be logged in onto the desktop of that machine at any given time. That's what it means with single user operating system. Now, Windows 10, as you know, is a single user multitasking, meaning it can do more than one thing once you're logged in. You can listen to Spotify, you can play a game, you can alt-tab between Discord. You can do a lot of things at once, and that's really important, but only you can do it on your machine. If I were to remote desktop to your laptop or gaming PC, it will kick you off. I will be able to log in to a user there if you gave me access or made a user profile for me, but you won't be able to use it at the same time. So single user. Then obviously you also get single user, single task operating systems. They are more rare. Older cell phones used to run that way. So one account, one thing at a time. You open another program, the other one has to close first. ATMs are also a really good example of a single user, single task. So essentially you as the client will be the user for that session and you will run each task on its own. You can't have a withdrawal and a transfer and deposit going at exactly the same time. It'll be in a series of events. It'll be one after another. Then obviously you get multi-user operating systems. Now, most people don't know this, but Mac OS is a multi-user operating system because of its Unix roots. So I could, like I show you here, create a profile for my wife, and she can obviously sit down in front of my Mac and log in and do things. But if she wanted to remote desktop to my Mac, either via SSH or through a client, she will be able to do so without me having to log off or kicking me off the system. So I can be here doing recordings while she's running a word processor in the background. I mean, that's amazing, but you also have to think that all resources is shared. So if she's pushing it too hard, then my things might stop working. So it's important to remember that you have to have a balance of resources and you have to have enough resources for every user that you have on a system. That's just an example of her remote desktoping to my desktop. Right, let's chat about a few specific kinds of operating systems. So we get the mainframe operating system, we get server operating systems. Now these are dedicated server roles like Ubuntu server or Windows server. Yes, they still have a user interface. Some of them have a graphical user interface. You can still do user things on it, but its function is geared towards being a server. Then the personal computer operating system. This is what most of us know so well. It'll be Windows 10, Mac OS, various flavors of Linux. Then your mobile phone operating systems like iOS, iPad OS, Watch OS, Android, back in the day, BlackBerry OS, which is now also Android. Then you have your Internet of Things operating systems, which are usually Linux-based. And then again, the real-time operating systems, which is also frequently a Linux or Unix-based system. So with that being said, most of you will know Microsoft Windows pretty well because most of us have grown up using it, and we've gone from, depending on your age, Windows 95, Windows 98, Windows 2000, Windows XP, Windows 7, Windows 8 for those that are really unlucky, Windows 10, and soon Windows 11, or you're watching this in the future, Windows 11. And some of you will be on Mac OS, which is got its own history and it's got its own thing, and we're going to go through that a bit later. And then obviously we get to Linux. Now Linux is an operating system that was based on Unix, and we are going to go through the whole history of this in Module 3, so don't worry about it just yet. Just know that it is out there and it's very, very popular, especially on servers. And in your second year, you are going to do a lot of work in Linux when you do forensics and hacking and those things. And you will, later on in your first year, you will do an entire course on Linux. So we're going to touch on the history of it, and we're going to show you a few things in it, but the really deep stuff will come a bit later. Then obviously, like I said, we have mobile and system on a chip operating systems. And scarily enough, these are now the most prevalent operating systems on the planet. Everybody's got a phone, everybody's got a smartphone. Most smartphones run Android or iOS, and they are starting to blur the lines because you can, like you did in the previous course, install Android on a desktop now. You can run iOS apps on a Mac if it's an M1 processor Mac, and we'll get to that in another lesson. So the lines between mobile and desktop is increasingly getting more and more blurred. And there will probably be a point in the future where you'll have a Windows OS, you'll have a Mac OS, or whatever they want to call it, Apple OS, you're going to have some Linux thing, and it'll be very much the same, or at least within that ecosystem, they will run exactly the same things. I know there's some big plans and they're testing and things are happening on the Windows platform where you will be able to run Android apps directly on Windows 11. I mean, that's pretty amazing if you think about it. You can already do that, like I said, on Mac if you have an M1 Mac because of how the processors work. But I think that's enough for today.